Hi everyone, and welcome to another of the TaskGen tutorial series. And today I'll be talking about tutorial 3, memory. As you all know, I'm very big with memory. I feel like for learning to happen, we need to consolidate learnings into memory and be able to retrieve such learnings. Hence, there's a very big emphasis on memory in TaskGen. The memory class in general has the two properties or two functions. One is append, where you can put in your memories, and the other is to retrieve, which is to retrieve them based on the task. And this memory is actually quite diverse. It could be images, videos, text. It could also be like summaries of text and so on. So you can do vector DB, knowledge graphs, chunks of text, and so on. And so I think all this memory class, it needs to be very versatile and you need to be able to use something that is suited for your use case. So by default, what you do for your memory, first you have to do the 3 steps, install, import functions, and define your LM. Then let me introduce you the memory base class for TaskGen. So the memory base class basically is a memory that is actually stored in a list. And this is a Python list. It's not stored in any database anywhere because I want to keep it generic and you don't have to have other dependencies. And essentially when we store it into this list and we have this top K variable, which will determine how much to retrieve. The top K to retrieve. This K by default is 3, like the top 3 to retrieve. And so over here, you can see that we have this thing like a mapping. And like here, we could have a way to map in an item that you put into the list. And when you do embeddings, you don't want to do the whole thing. You just want to embed only what is important. So like, for example, if your function description is important, then you can, instead of mapping the embedding on the whole thing, which is what is done in most databases, you could set up a mapping function such that you only map the function description. Okay, so by default, top K is actually 5. So by default, what we will do is we will have a function memory that will help you do rag over the functions. So if you have more than 5 functions, what will happen is that based on semantic similarity to your tasks, we will filter out the top 5 functions only. And here you can see that there's also an approach called retrieve by ranker, which means we use embeddings. There's also a retrieve by LM, which uses the LM to compare to see which is better. The LM is more accurate, but it costs more, right? So first, let's try to filter functions by task. So top K is 5. And what we'll do is we'll do this. Okay, let's run this code here. So we define a lot of different functions. Here you can see this is how we define functions in TaskGen with the function name and then the function variables here. All right, and here you can see that we just need to put in like num list inside your doc string, and then we can generate the function description for you automatically backend in TaskGen. So these are the different functions defined by the function definition. All right, if let's say you want to bypass reg, you want to make sure that function is always present, you can just put is compulsory equals to true when you define the external function like this in a function. You cannot do compulsory is true inside this Python definition. You need to put the definition inside a TaskGen function in order to bypass reg. And of course, we also have internal functions where you can just put in angle brackets your variables with their types here. Okay, and then the output format. And then here we can have the function names and so on. Yep, so this is basically using LM to do stuff like generate a poem given 2 numbers, num1 and num2. So let's run this, assign all these functions to your agent. We set default to LM is false, which means that the agent cannot use the use LM function so that, it doesn't hallucinate certain things. It will have to use one of the functions that we provided. So we can see what are the list of functions. Here we can also print out the functions to take a look. So you can see we have end task, sum of numbers, subtract numbers, multiply numbers, divide numbers, the power operation, greatest common divisor, modulo, absolute difference, generate poem with numbers, and list related words and generate code. So here we can see we can configure the top K by using this myagent.memorybank. You can see that if we just run myagent.memorybank, we have a function here and we can have, this is the TaskGen default memory, right? You can also put in your own kinds of memory by just simply saying, your memory here. And then you can just put like, memory, and then you can just put in your list of memories here, like this. Okay, but I'm not going to run this. Okay, this is just for information. right? We can see like if we ask it to evaluate 3 minus 1, let's see what are the relevant functions that will be retrieved. And note that this top K does not include the compulsory function. So earlier on, you saw that there was a compulsory function here, some numbers, which will always appear regardless of task. It's not appearing here, all right? So this, you can see subtract numbers appears quite high on the list, which means that it understands the semantic meaning of this. Right? Just to let everyone know, as I experimented more with agents, I realized that giving too many functions may not be a good approach. But if you have really a lot of functions to give, this rack-based approach to function filtering is quite useful so that we don't overload the context of the LM with too many functions. It's important to limit the number of functions for greater robustness in the output. So let's run this simple task of evaluate 2 plus 3. You can see that the filtered function names appear at every step here. And indeed, sum numbers is that. So we can sum the numbers. And we have our answer, 5, okay, which is correct. Now we try to run this quite complicated equation to the power of 10 times 3 plus 5 divided by 10. And, through doing some form of like React framework where we have observation, thoughts, and actions. We can first do to the power of 10, then we do 3 plus 5, then we multiply 1024 by 8, and then divide 8192 by 10. And we can see we ended the task successfully. And you can even see what are the different thoughts for that. Like these are the observations, thoughts, and the subtasks. For each step, you just need to put myAgent.thoughts, and you can retrieve all the intermediate thoughts as you need. Then you can reply the user based on what has been generated. Let's take a look at what has been replied for this. You can see this is answers 819.2, which is correct. So we can check the status of the agent and, yeah, so basically this tells you what all the subtasks completed. And you can see that the list of functions is so much, but when we actually come to compute it, we actually narrowed down the functions like this based on the tasks at hand, right? So now let's go on to the next part where, sometimes you don't want to put all the context all at one go to the large language model. You want to only, like, based on certain tasks, you want to give it more context based on the task itself. So like, for example, you can put in your memory bank a task instructions and, like, for example, for John, generate a poem about the sun, for Mary, about the wind, for Peter, about the sea. So we don't want to overload the LM with all this. Only when the task is similar, like John, Mary, or Peter, then we put in this in the context of the agent. Right? So by default, everything in the memory bank will be retrieved by top K and by the retrieve function. So basically, if you have different memory banks, like function memory, different kinds of other memories based on the different keys you have here, we'll just retrieve the memories according to the retrieve function of this memories, right? So you can define, like, for our base memory class, you can define top K. So over here, top K, we choose top 1, all right? So let's run this, and then we can see that. All right, let's run my agent.run John. And in this case, we should generate a poem about the sun. So you can see in the description of the agent, we did not have anything about the sun, but because of this memory here, we generated a poem about the sun. So task done. And now we can run Isaac Newton, which has nothing at all, okay? Because we did not give, like, any specific task instruction about Isaac Newton. So over here, it just generates a generic poem about Isaac Newton. So this is how you can, get diverse outputs just by putting your task instructions here as a memory. So this is pretty cool. I encourage you all to try it out. All right. We also have some other things that, you could directly read from certain files. The list is expanding, but these are the current files supported: PDF, docx, CSV, XLS. So there's a sync version and an async version of the memory. This takes about 2 minutes, so I recommend just running the async version. Async is really much faster. So this, it should take about 5 seconds or so. So be about 6 seconds. And this basically goes to the file react.pdf and asks it to retrieve the chunks that are similar to this, what is react. So yeah, if you can print out this, you can see the chunk printed out. But what we can do is we can use this memory and we can run, all right? We can basically just put the document to be this async memory, which are the chunks here. Okay, and what we can do is we can ask, like, what is react, and then it will retrieve based on this async memory here, which is actually the chunks of the file, right? We can actually retrieve the chunks that are related to answer the question. And here you can see React is a framework that used to handle variety of tasks with different action spaces and reasoning capabilities and so on. So yeah, this is pretty cool because it's able to get the chunks out. So I mean, we could just, we could run this directly like this, and we can see what are the chunks retrieved. I mean, it's quite interesting to see. So this is the chunk that is retrieved. All right. So this is when top k equals to 1. Right. I mean, if we put this top k equals to 3, let's run the whole thing again and see what we retrieve and what the answer will be. So you see, you can just configure your top k like that. So it's pretty cool. So we can see what is react. Let's see what memories are retrieved. And so this is chunk number 1, this is chunk number 2, and this is chunk number 3. So maybe this will give a better answer because, like, now it has more chunks. And actually the quality of the response depends a lot of the quality of the memory that is stored. So chunks is actually a very rudimentary form of memory. If you can put stuff in knowledge graphs that have more fixed relations, or you could just even do kinds of like summary memories, large scale memories, and just do different pipelines to retrieve them. It might be actually better than just doing chunk-based retrieval, right? So I leave that for future work. You can see this is the answer now. Wow, see, it's even much more accurate now if we just do a top case tree. Right, there are different other things that we have done. So like Prince has created a ChromaDB memory where we can store things in ChromaDB vector database. And like we also have a mapper function that allows you to embed only based on that mapping. So you can see that in order to use this, we just basically create a ChromaDB memory, call your collection name, put your mappers and so on. Okay, I will not run this code here because I think it's quite self-explanatory. So you can see like how to retrieve and how to append. So essentially memory class is just about appending and retrieving. And I really encourage everyone to consider contributing your own memory class. We are really looking for contributions to really buff up this framework so much. Like right now, the memory class, we just need append, remove, reset, and retrieve. So this remove and reset is mainly for the users to just reset the whole memory, but it's not that crucial. Okay, the main thing is the append function and the retrieve function. So append, given the memory list, how you want to append your memories to either database, knowledge graph, or some new memory structure that you have never even seen before, right? And how you retrieve these memories as well. You can see the example notebook for memory is basically this is the version of the base memory that is implemented. So this is the simple version that uses OpenAI embeddings and just retrieve based on embedding similarity. So of course the one that we use is a bit more complicated. You can put your own embedders, you can put your own mappers and so on. Here to simplify, I actually did not do all this. So this is just a template for list memory. And yeah, so that's more or less it for memory. I think this is a very important tutorial because how we learn really depends on how we store information in memory and how we retrieve them. And dynamically updating this memory, like for example, reflections at the end of your task, dynamically updating it is so crucial for learning. And I think I'll cover all these things about how to do dynamic memory and so on in another tutorial, not this one. This one is just to teach you how to use the memory class. So just a summary, two kinds of memory. One is a function memory that selects the functions according to tasks. And the other memory is your own configured memory where you can, put in the different kinds of keys, like for example, task instructions, documents, and so on. And yeah, I look forward to you using this and let me know your thoughts. And signing out.